Welcome to tbtalks.com. We want to advance. We are still exploring organic chemistry, which is one of the branches, fundamental branches of advanced level chemistry. And we have been looking at the uniqueness of carbon, and now we're going to look at how to get empirical formula, structural formula, molecular formula, how do we obtain them, and how relevant are they to this branch. So I want to look at empirical, and structural formula. But we're going to start looking at empirical, and we need to quite understand clearly the meaning of the word empirical. Empirical formula. Yeah, this is just a formula. It is a formula which expresses the ratio of atoms in 1 mole of a molecule. Now, in 1 mole of a molecule, the molecule could have so many atoms, but what is the ratio to them? Take an example. If I'm having butane, which is C4H10, there are a total number of 4 carbons and 10 hydrogens. When we sum up all of them, we get 14 atoms. But what is the ratio of carbon to hydrogen? Ratio of carbon to hydrogen will equal to 4 to 10. And when we express it in the simplest ratio, we obtain 2 to 5. So 2 to 5 defines the empirical formula. In other words, somebody can say that empirical formula of butane is C2H5. That is the empirical formula. So empirical formula is all about, is a formula which expresses or which helps us to define the ratio of atoms in 1 mole of a given molecule. However, atoms could be more than 2, because here I'm only looking at carbon and hydrogen, or a hydrocarbon. But some compounds could have so many other atoms. It could be carbon, hydrogen, and sulfur, or oxygen, or nitrogen, or whatever. But we're looking at the ratio of all of these atoms. That is empirical formula. Now, we want to advance and proceed with the molecular. Molecular formula. Now, molecular is developed from empirical formula. They are almost the same, only that with empirical, we are focusing at the ratio of the number of atoms in 1 mole of a molecule. But molecular looks at the total number of, it expresses the total number of atoms, the actual number of atoms in 1 mole of a compound. This one expresses the actual number of atoms in 1 mole a molecule. Yeah, that's molecular formula. We are saying that molecular formula simply expresses the actual number. If 1 mole of a compound is a hydrocarbon, then it looks at, in a hydrocarbon, then I should have carbon, I should also have hydrogen. But how many number of carbons do I have? How many number of hydrogens do I have? That defines molecular formula. Take an example. In butane, remember I'm using butane as my case study. It is C4H10. So, the molecular formula means we have 4 carbon atoms in 1 mole of butane and 10 hydrogen atoms in 1 mole of butane. So, that total number or total actual number of atoms in 1 mole of a molecule is what we refer to as the molecular formula. Now, we can advance to structural formula. Structural formula. Structural formula is the formula which expresses or shows the bonding of atoms within a molecule. Yeah. Take an example. We have said empirical formula expresses the ratio of the number of atoms in 1 mole of a compound. Then when we came to molecular, we are saying that molecular formula expresses the actual number of atoms in a given 1 mole of a compound. But then structural looks at these total number of atoms, how are they bonded one to another? Are they bonded 1 to 1? Are they bonded 3 to 3? Exactly how are they bonded? So in other words, structural formula shows the bonding of atoms in a molecule. It shows the bonding of atoms in a molecule. Just like we said, our case study is C4H10, which is, we are calling it butane. If we are looking at the structure of butane, then we ought to look at how are they coordinated. The coordination is the bonding. Look at carbon. You can say carbon is here. It should be connected to carbon, connect to another carbon, then connect to another carbon. They are able to connect it because they are carbon atoms using the fact of catenation. Yeah, this property of forming rings and chains is what we refer to as catenation. Now, we start attaching. Actually, this is the bonding. These are 4 carbon atoms. The structural formula is showing you how the 4 carbon atoms are bonded to one another. But then within the butane, we don't only have carbon atoms, we also have hydrogen atoms. How are they all bonded out together to form an overall molecule? So that would call us to look at the covalence of carbon. Carbon should have a maximum of 4 bonds. Each carbon. These are 3. Those are 1, 2, 3, 4 bonds. These are already 2 bonds on carbon. Then we introduce other 2 hydrogen atoms. Only that we make sure that the bonds are not hanging. Should not draw a bond like you're drawing carbon, then carbon. This is a line, not a bond really. The bond should be touching between carbon and carbon. So another one could be here, and then the bond should not be exceeding like this. This is protruding. The bond should not be protruding. The bond should be reaching where it is supposed to be. Okay. So this is what we're referring to as a structural formula. We're saying that a structural formula shows the bonding of atoms in a given mole of a molecule. Okay. Now, from structural formula, we go to how to calculate empirical formula. How to calculate empirical formula. We normally have a few steps which we should follow for uniformity, that whoever learner is trying to calculate empirical formula, for uniformity reasons, we need to know a few steps. Actually, we need to know a few steps. Number one, we need to identify elements. You are going to calculate empirical formula, but the formula you want to obtain has which elements? Is it carbon? Is it hydrogen? Is it magnesium? Is it what? We really need to identify the elements which are going to form a compound that we're trying to find out. After identifying the elements, then we identify the mass. It can be mass or percentage composition is. Now, this one depends on what the question has really presented. Some questions could present the masses, some questions could present the percentages. Whatever you find easy or available is what we use. We need them so much. Then from here, we need to get number of moles. And this number of moles equal to, how do we obtain them? Depending, if you have the mass, then you tell me mass out of relative atomic masses. Or if you have the percentage composition, you'll have the percentage out of still the RAM. That is how we really obtain the number of moles. And then after obtaining the number of moles, we go ahead to obtain the simplest ratio. Now, we should really be serious and call it simplest ratio. Because after obtaining these moles, we are going to look at very many moles of different elements in a given compound. But then we identify the ones which are smallest, divide them throughout. That's why we call it simplest ratio. Now here I want to give an example. I could say I'm having carbon to hydrogen to oxygen. When I have here 0.01, 0.005, 0.06. I'm showing that these are my moles. If those are my moles, then I look at, out of these three different moles I'm having, they look for the smallest values. And when I look through, the smallest value could be these ones of hydrogen. Then I divide it throughout. And I say, I'm now getting the simplest ratio. I'll say this is 0.01 out of 0.005, 0.005 out of 0.005, 0.06 out of 0.005. So the answers which I get are what we refer to as simplest ratios. Please, we don't just divide anyhow, but we look for the moles that are smallest and then divide them throughout. this would definitely give me 1 here, and when I divide here, I will get 2. I'll get 6 here. So these are my simplest ratios which I've really obtained. The simplest